Hello, good morning, everybody. My name is Swati, and I am graduate fellow for this project. We are delighted to be here, and we feel grateful to be able to present this project here. Our project is Data-Driven Insights for Local Food Markets, Artificial Intelligence, Pricing, and Crop Flow. In our project, we have aimed to reshape our local food markets and optimize the flow of crops. So this was our main focus on the project. With a strong passion of both technology and public good, we bring you valuable insights and outcomes for local food markets. Before delving into the details of the project, I would like to introduce my whole team here. I'm Swati. I am majoring in Management Information System. I'm the graduate fellow. In the team, we have Aaron, right beside me. He is an undergraduate student majoring in computer science. We also have Sadat, who is majoring in artificial intelligence. He's a graduate fellow for our project. And we also have Harun, who is doing PhD in history and has helped us throughout the project with all the technical difficulties that we faced. All right, let's talk about the project now. I'm going to introduce the project, what it is, and how we planned on doing it, how we did everything in past 2 weeks. So our overall goal throughout the project was to enhance local food markets by providing useful insights and improve the way crops are managed in Iowa. To start, we focused on 3 common and locally produced food items: eggs, bacon, and tomatoes. So the reason we chose these 3 are because they are very common, they are unprocessed, and they are locally produced. We begin with what, how, and why. In what, so what basically is what we plan to achieve, then how we plan to achieve, and then why it is important. So we planned our project in 4 segments. So we planned on producing 4 outputs. The first one is going to be a web scraping tool for data collection, because we realize data collection is tedious and time consuming, and sometimes the data that you get cannot be accurate. So we thought of creating a tool that can automatically scrape data from websites and can automate the process, basically saving your time and getting more accurate information. Then in order to see how a tool works, and in order to ensure that our tool is not only meant for the 3 products we chose, we also wanted to try our tool on some other product, yes. And we did a trial case of this on carrots, and the tool worked very well. We were able to get data from for carrots. We're going to talk about it later. Aaron's going to talk about the spiders in a bit. Then we also planned on analyzing all the data that our tool collected. So, and then getting all the insights, what we get through visualizations and all that, so that we can share our insights and how that can be useful for the farmers. And lastly, we also planned on creating an optimization flow of crop that will showcase us how the overall profit of a crop can be maximized. Basically, knowing where the demand for a certain crop is needed and where there is a surplus of that crop across the Iowa. Now, how we plan to achieve, this is kind of like a roadmap that we made for ourselves, and we tried sticking to it throughout the project. So for spiders, for web scraping and specifically spiders, we followed a systematic approach wherein we manually collected data. We went to all those websites that we wanted to scrape. And then we started writing codes for scraping, and a lot of testing, a lot of debugging, and all that thing. Then, um, as I spoke, we tested our tool by tried by testing if we can scrape data for a different product other than the three that we are using, and then we will showcase the insights our data is producing, and finally we're gonna be working on the optimization of cross flow. Now, why we think this is important? So we think investigating a data pattern for common products will help business make decisions. It will also help businesses stay competitive in the market. Also, data collection through a tool that can automate the whole process is going to save a lot of time. Also, it will ensure that the data that we have is accurate and is errorless. I mean, data cannot be accurate always, but yeah, the tool can still avoid any human errors that we may do. By crop flow, we can that the farmer who is selling the crop and the buyer who is buying the crop, both are benefited. All right. The project, I have Aaron here who's going to be talking about the web scraping, how we did, how the tool is made, and yep.
All right, how's everybody doing today? All right, let's get into this. Okay, from last year's projects, we had a bit of success, like with gathering information from using web scrapers that they used or they built last year. So the problem with this year to last year is over the past year, the websites that they were able to scrape, the websites changed. So that just means whatever they did is now obsolete. We can't use any of that. So we had to go ahead and make a new tool. So to ensure the success of the current projects, we need a whole bunch of data. We can't just go out and scrape data because that is really, really tedious, as Swati said, and it takes a huge amount of time. So for part of the project, we spent 3 days gathering information. We only got a little bit. It was not successful and it was not feasible by hand. And manually doing this, it was not like possible in the scope of time that we had. So, and we started to build tools, and that comes into the automation. In simple terms, the tool that we used is a spider or a web crawler. This program is essentially a program or script designed to specifically automate web scraping navigation and extract data that we want. These spiders can not only replicate what the last year project did, but also improve it and blow it out of the water. So we're essentially handing the baton and setting the future project up for success. So this is the general procedure of spiders. We have a URL, and from that URL, we go into the page and systematically traverse the page, moving from the websites and gathering data from each of it. So we analyze what we want using XPaths and CSX selectors. You don't really have to know this stuff. It's basically how the spider looks at the page. So this right here is an example of how it would see the web page. It's very different from how you and I would perceive it. So does anybody know like HTML or CSS? Oh, okay. So from this, we gather the elements from the page, which are the text, the images, everything that you see on the page. So like the buttons, we have pressed the button and it goes to a different page. This is part of the process that we do. And then once that's done, we extract it and store it. And that is just like the basics that I didn't really go into too much detail. I hope I didn't confuse anybody here. Um, Now for our spiders, we follow this procedure in comparison to the general one because we do a bit more and we want some accurate information. So we start off by the URL and then we travel through the website and then we use the pathing like the CSS and X selectors, stuff like that. And then we scrape the data and then we extract it and collect it. Now this is where it changes a little bit. So this raw data that the extracted data is raw and it is very different from like what we need. And it's not really the text, it's a bit more than that. So we need to clean that up a little bit and store it into a CSV file so we can move on to the next spider. Why we make multiple spiders is because you have to really program it to do a specific task. If you don't program it to do anything, then it won't do anything. Page sites are different, websites are different, pathing is different, everything is different. So we can't really just make a spider for everything. We have to program it to do things. Once we're done running all of our spiders, we merge the CSV files, and then we clean this data thoroughly and add it to what we need it to do. And then we move on to data analysis. So these are all the websites that we were able to scrape. This is an example of the store page that we would scrape from. So we would take in the price right here, the name, everything. We would click on this image and it would go to the next page. That's part of the scraping process. And then from that, this is an output of all the spiders. We have all these files right here. These are all the CSV files. Down here is the master files, the files that we combined and merged and cleaned. This is an example of one of these files, specifically I believe it's the Gateway Tomato Market. I think it's this one right here. So from here, we collect all these datas, and sometimes we can't really find some things, like average weights. We can't really do anything with that because we need the actual weights, like the pints. Each thing is a little bit different and we have to specify this. This part is very, very tedious. So is the brand. Sometimes we don't get the brand and that is just how it works. In a perfect world, we would have everything available and it would make everything a lot easier. Down here, we have the actual clean data and everything is combined and merged together. These blue indications are representing sales. So we can tell if there's a sale. The website makes everything available. So it's super easy to see what we need and what we were able to extract. As Swati said, we can expand these spiders to other products. Here I have a list of all the products that I was able to scrape and like have available. So it's very, very easy to expand. This is an example of carrots. This is like the raw data that we can extract. So we have like the amount of carrots that we need, the price, sale price, if there is one, the location, the URL, we have everything. And from that, we move on to data analysis. So we can, process our newly extracted data.
All right, now we're going to be taking a look at the data analysis part because after spiders, we had data. The data was not very clean, but yes, we had some data that we can start working on. So before we could go for the analysis part, there was a lot cleaning that was done. As Aaron mentioned, products that were available on the website were of same weight. Example, some of the products were being sold at for 2 lbs, some were of like 1 lb or some less than that. So we had to just get all of them like in one fashion so that can be, the whole CSV could be ready for further analysis. All right, the data analysis process, we approached the regular data analysis process. That is, we first define the question, like what we are trying to get from the data. We had a list of questions that, okay, these are the things that we want to get answered from our data. Data collection was done, spider, tedious, very tedious part. After that, the analysis come into picture. I'm going to take you through the analysis. So for an analysis, we started with bacon, then eggs, tomatoes. We not consolidated all the three data sets into one because we wanted to see insights of all the three products differently. I'm going to talk about bacon first. Now, this shows a bacon price distribution among all the stores. It is categorized in local and non-local. Now, all the stores that are in purple color sells local as well as non-local bacon. But if you notice, Iowa Food Hub, that is in yellow color, and Fresh Thyme, these are the two brands who either sell local bacon or sell non-local bacon. Now, how this can be useful for farmers? Opportunity to directly supply their product. It also helps the farmer establish partnership with the brand and secure a stable market for their products. Also, it also promotes a sense of community and supports local economy by keeping the money within the region. Now here, this one shows the average bacon price across all these stores. Now, knowing this can help our farmers with informed decision. They will know the average price that is going among all the stores, and they can decide what they wanna, at what price they wanna sell their products at. It also gives farmers a negotiation power. So if a farmer knows the typical market rate, they can confidently negotiate fair prices that aligns within the average, preventing them from being taken advantage of during negotiation. Also, it can help them with their with competitive analysis. For example, if they find their product price significantly higher or lower than competitors, they can access the reason behind it. Farmers can adapt their marketing or branding or product offerings accordingly to stay competitive and attract more and more buyers. Now here we have Iowa map, and we can see the prices of bacon. Now, on the left side, we have local bacons, and on the right side, we have non-local bacons. One thing we noticed in this map, right, the lower, the more, I mean, the more southwest you go in the Iowa, the prices of bacon are cheaper. But the more northeast you go, the prices are higher. So that could be important thing for farmers to notice. Next product, we have eggs. Again, we did the same thing for eggs, price analysis for eggs, and then categorizing it into brown, white, and mixed. We were not expecting duck eggs, but we found duck eggs as well. All right, now, when we come to the count of available egg brands, we can clearly see most of the brands that we have in the market prefer to sell brown eggs. We can infer from this, we cannot guarantee, but this somewhere shows that brown eggs are more popular. And that is why sellers are considering selling brown eggs more in their stores. Now, since we have duck eggs and chicken eggs, we thought of categorizing them. So this is chicken eggs, organic and non-organic price comparison. We can clearly see that organic eggs are on an expensive side when compared to non-organic ones. And we know why that is, because organic eggs it takes a lot of effort and time to produce an organic egg. So understanding this whole thing, it can help farmers emphasize the unique qualities and benefits of their organic egg. Talk about their marketing efforts that they have put in. They can highlight factors such as superior nutrition value, sustainable production practices, and animal welfare standards to justify the higher prices of organic eggs. This can attract customers who value organic and are willing to pay for a premium for it. Now, in this visualization, we have retail price versus brand. So the brown block shows the brown eggs, white block shows white eggs, and the peach one shows mixed eggs. So the brand Pete and Gary's eggs, they are selling their brown eggs at the higher price when compared to all of the. So the bigger the block is, the higher the prices. In the case of white eggs, Fresh Thyme and Farmers and House were selling their eggs at a higher price. There was nothing to notice much. Now here we have chicken eggs, organic versus non-organic distribution. One thing to notice in this visualization is that when you go all the way down, you can see Brewer Creek Farm only sell organic eggs. So this could be a chance for farmers who are producing organic eggs to reach this brand so that they can attract more customers and they can gain, they can run their business for a more profit. Now here we have a chicken eggs local and non-local price comparison. One thing to notice here is that in the case of organic, there is not much difference between local and non-local. But when we talk about organic, I'm sorry, I think, yeah, it's the opposite way. In the case of local, if the product is non-organic, and in the case of non-local, if the product is still non-organic, there is not much difference between the prices. But when we talk about a product which is local and organic, and a product which is organic but not local, there is a significant price difference. This gives an opportunity for farmers to promote that if you buy eggs local and organic, they're going to be cheaper when compared to the eggs which are non-local and organic. All right, just a price comparison of chicken eggs versus duck eggs. Duck eggs were way expensive than chicken eggs. All right, now we have tomatoes. In tomatoes, we again started categorizing them in local and non-local prices, and we also wanted to see the organic and non-organic distribution. So if a tomato is local and non-organic, price is very less, but if it is non-local and non-organic, the price is high. This was unusual. I mean, the product is still non-organic and non-local, then yeah, this was surprising for us too. All right, in this price distribution in different stores and cities, organic versus a non-organic. And we can clearly see that the city, Cedar Rapids, does not have organic tomatoes. We are not claiming this is exactly true, but this is from the data set that we have. Next, we have price distribution in different stores and cities for local and non-local. And in this case, Glenwood only had non-local tomatoes. Last one, we have price distribution, current price by brand. And looks like this brand here is the only brand that sells local tomatoes when compared to other brands. So these are the few insights that we could get. We do not want to claim that this is exactly true because I want to be honest, the data set we had is very small. But we gives an opportunity here that if the same kind of stuff is done on a bigger data set, then a lot more information and a lot better things can be derived. I think for next part, I would like to pass the mic on to Sadat. He's going to talk about the optimization of crop flow.
Hi, everyone. In the previous section, we have seen that the price varies across different stores and different cities. That gives the local food farms an opportunity to sell their products in a high-priced area. And in this section, we will analyze the crop flow distribution for local food farms to maximize profit. In this case, our objective would be to maximize the revenue through crop sales while still considering the transportation cost. I want to say that we have not considered production cost in this model because production cost is nowhere relevant to the transportation units, and it will not affect the transportation units or the distribution of the crops. So to show our approach and how we did that, we have used tomatoes as an example. For to be very specific, we are trying to find out the distribution of tomatoes during 8 week of timeline. That is from late July to mid-September. This is when tomatoes are harvested in Iowa. And our approach involves 4 things. That is, first, we start with demand and supply estimation. Then we visualize the demand and supply across Iowa in a map. Then we develop the optimization model. Then we show the results of the optimization model in the map. So now I will talk about the demand and supply estimation first. So we have followed our approach, and within that approach, we was able to get the demand and supply as shown in the screen. In our approach, the supply and demand ratio for tomatoes was 0.06658. There is another model that is available commercially, that is in-plant model. They don't have data specifically for tomatoes, but they do have data, or they have the supply demand ratio for, in general, vegetables and melons. And that is 0.380. So we can see that our estimation approach somewhere is closely aligned with their estimation approach or their number. So we can say that although we have done this for demonstration purpose, but these are some reasonable numbers we were able to get. However, if you like to know how we get these numbers, I have a separate blog which shows a detailed approach how we got these numbers, and I can show you later. Next, we plotted the supply and demand information across the Iowa map. In the first step, we have the supplies of tomatoes. We can obtain the information about supply of tomatoes. The color gradient varies from light blue to deep blue. Wherever the color is deep blue, that means there is more supply compared to the light blue. For an example, if we hover our mouse over Sioux County, we can see that the supply is 4.477 metric ton per week. And if we hover our mouse on a light blue county, for example, Fremont County, our supply was 1.475 metric ton per week. Now, similar thing can be obtained using a similar thing is shown in the demand tab, where we show the information related to demand. And in this case, the color gradient is from golden to deep red. And if we just move to the reddest part of the graph, that's the Polk County, the demand is 88.72 metric ton per week. So we can see that there exists a great difference between the supply and demand across the counties. And we try to plot that on the map as well. Then we plotted the demand and supply difference on in every county. And here the color gradient ranges from deep blue to deep red. Deep blue means that there is a surplus of supply, and deep red means there is a severe deficit of supply. For example, if we hover our mouse on the Polk County, it shows that there is 86.58 metric ton per week deficit of tomatoes supply. On the other hand, if we just go to a different county, let's say Page County, so there is a little bit balance between supply and demand, and it's 0.64 metric ton per week. So let's move forward. Now I need to say something why we need a combined strategy among all of these counties. First of all, let's imagine that a county is acting alone. In order to maximize its profit, it will try to sell its crops to those counties that are ready to purchase crops at high price. The county will also take account of the transportation cost. In this scenario, every county will try to follow the same approach, and they will be competing for the same set of counties. Like all of them will try to sell to the same counties. This will make an influx of supplies. That means the supply would be very, very high in a county, while the demand, it may exceed the demand very much. So I'm trying to say that in this scenario, the price may drop, and furthermore, there would be some other counties that may not meet the demand it needed. So that's why we need a combined strategy instead of acting alone. To provide, now I'm going to demonstrate the optimization model. To provide a demonstration, we have selected 24 counties out of 99 counties where the supply and demand gap is relatively modest. And in these counties, we have simulated the price. We didn't have enough information about the tomatoes price for all of these counties. That's why we simulated the price using a normal distribution. And for our analysis, we have used Ford F-350 truck with its carrying capacity and mileage. And we have used Gurobi optimization solver to solve it. And this is the data set that has been used in the optimization model. And we can see the solution, and we plotted the solution in the IWAM map. In the first image, we can see the bubbles are the origins. So if we hover our mouse on this bubble, it will show how much quantity and how much quantity it needs to supply to other counties. And if we hover our mouse on a line, it will show how much quantities is being transported from to where, and that's it. And on the right-hand side, we have put the bubbles on the destination. This is exactly same graph as before, but we just have the bubbles on the destination. In that case, if we hover our mouse over a single, let's say this one, hover our mouse on a bubble, it will show which counties which counties are supplying their product to this county and their relative and the quantity. So next, we want to talk about the profit retrained in collaborative strategy compared to operating individually. So let's consider a hypothetical scenario where only one supplier exists and all of them are receiver. So one supplier can sell their products to the highest price area. For example, let's consider that this is the Benton County. Benton County is able to sell to these 24 other counties. And in that case, it will have the maximum profit because it doesn't need to compete with other counties. And at the same time, he would be able to sell all of his crops. So this chart shows the ratio of crop flow strategy that is obtained from the collaborative strategy and the hypothetical scenario I have just shown. I have just told you. And this profit retained shows how much profit it is making compared to that best scenario. And this numbers varies from 80% to 100%. So these numbers actually kind of show how the farmers are going to accept the combined strategy and how they are going to accept it, or should we change the strategy a little bit so that they get a similar number in place. So in terms of limitations, we have used Euclidean distance. That means we have taken 2 points and measured the distance using the Euclidean method. We could have used the real world distance using Google API, but for time limitation, we couldn't do that. I hope in future it could be done. And the next thing is we have accepted partial truckload in this optimization model, which we can limit to full truckload only. That means a truck cannot go if it has, let's say, 0.5 truck, 0.5 partial load. This is it. And in total, I will talk about the future work for the project. First of all, the spiders can be improved and optimized in general. We can implement parallel processing for the spiders. We can make more spiders for different or additional websites. We can explore other web scraping method. And after we have gathered all those data, we can generate further insight by analyzing more data using data analysis. And for the optimization of crop flow part, we can focus on the profit return section more carefully than other parts. And we can also integrate of where to plant crops in the optimization of crop flow model. In conclusion, our project is aimed to enhance local food market by providing valuable insights. We have provided 2 tools. The first one is web scraping tool. Web scraping tool is essential to build a comprehensive data set. And using those data set, we can do the demand forecasting and crop management as a part of application of AI. And then we have gathered so many insights using data analysis. And finally, we have another tool, the optimization model, that will show or give us a best strategy when everyone is present or everyone is in collaboration. So in summary, the project holds significance as it provides valuable insights and tools and tries to have farmers take informed decision-making, and it empowers businesses to stay informed about the market trends and optimize the allocation of resources, thereby contributing the growth of long-term sustainability of the local food and farm sector. That's all. And we have used this data source and software tools. If you have interest, you can just take a look. Thank you very much. Do you have any question? Yeah.
Just asking if, what was the biggest surprise? Any
Oh,
surprises
okay,
on the
so
project?
we worked on 3 different parts. So I can say what was the biggest surprise in my part, and they might say what was the surprise in their part. In my part, if we go to this picture, we can see that the county Boone is providing crops to other counties. So in reality, Boone is not fulfilling his demand. He is fulfilling the demand of other counties because they were selling the products at high prices. This was my surprise.
I think in data analysis, we created few other visualizations, but we just didn't want to overwhelm you guys. So we did not include those. For example, we created a discount chart wherein we were getting insights on which brands are giving more discounts when compared to other brands. So also we have like many other visualizations that could be found on our blog page. So yeah. Any other questions?
I have a question. So you mentioned, Swati, that when you're doing your analysis, you didn't have that many records of data to do it with. So how many records were you dealing with? Was it different between the 3 commodities?
I can tell you exact numbers because I was able to remember. It was very small number. In tomatoes, we had 50, just 50 entries. In eggs and bacon, we had a little bit more. For example, in eggs, we had 76 entries. And in bacon, we had the highest entry. I think we had around 80 or so. Yep, sure.
Okay, so we did 7 different grocery stores. Those were the ones that we were able to scrape. However, we have, like, we can expand it to any number that is given. It is the entire store page. So if I had a little bit more time, I would have done like each chain or each location of the store. That would have been, we would have gotten a lot more data. But yeah, we had a bit of problem with Ivy because their API it was not friendly, to say the least. About everything else, like I think Fresh Theme, there were multiple locations. It was just Hy-Vee. We had trouble getting the store location and collecting those like separate data, but everything else was peachy. Anything else?
So when you were describing the spider and how it crawls through the website to gather the data, is this happening constantly? Is it happening one time? Can you explain that process?
There's a lot of ethics on spiders, and I made sure to like not overwhelm the website because if you make too many requests, the page is going to put stress on the servers and it could cause damage. So each time I do a scrape, I make sure to have a delay of every single time that I make a call, and I don't use anything on the page that I don't need. So like I only use text, and if I have an image, then I will follow the image to the exact place where it's stored and just save the URL. That way I'm not downloading anything. I'm just making a call to another page, and then that's done. It's already back to the original page. So not it's so each product you would call in the website and then you would go to the product page. And then from that product page, we get all the information and then we step back. Or we're already back at that point. We're just making another spider to crawl along there. It's kind of like, yes, it's happening at once per spider. So one spider will run and then it'll go through to the next one and then go to the next one. So we're not overwhelming each website. No, just one. Well, yes, we'll have to do that. Like, no, that we would have to do that for like one time per month or something along those lines. Does that? Yeah.
Right. I mean, so one of the things they have to do is you're testing it out, seeing how you can automate this, make this work so we can start to collect the quantity of data required to do the deeper analysis. But in terms of, we had a lot of discussions about ethics and scraping. Is scraping legal? It is. But it still does, you are going to the machine and you're making requests. But honestly, if you were doing your individual, if you were going there individually and looking at the page and going and following each of the links yourself, you're also doing the same number. You're doing those same hits, those same requests, and doing it just that you're then grabbing it in your mind, writing it down, or copying and pasting it. This just automates that because time is the item of essence here. Because if you want to do what Bailey was discussing and have the ability to start to do trend data or any type of forecasting, you need the massive amount of data and just humanly possible within the time frame.
Okay, I was just gonna mention how great the team was because we did not have data like they've mentioned. And so I think my surprise from the project was figuring out the process to use in the future. So since we tested it in a retail setting with a handful of grocery stores in very limited locations, the spider being a model or this like the supply chain model fits into several other projects. So there's connectivity and partnership that I think is showing up from that process. So for example, right now we're looking at retail and consumer prices, but we're not finding out production prices, I think was mentioned for a product. We also have a project going on like farmers market pricing, and that's a different way of aggregating data. So there's just so many different data sets that makes it really complicated to figure out this question. But we are having future discussions about how to utilize this process that was identified in future years. So that's been cool to figure out.
Yeah, we should mention the plan is that this is year 2, but year 1 of the refocus of a 3-year project to try and dig into this based upon what they learned in last year's DSPG. So they did a really great job, I thought, getting into it and have to figure out a project that was a little bit ambiguous at moments because like I said, there was no data. And what can we do? Well, we don't know what we can do because we don't know what we have to do it with. So they had a lot of questions to answer. Other questions from the group or online?
So one more thing I would like to add here is, so the data set that we worked on nowhere exists on the internet. So, yeah.
Thank you. So I worked with this project last year, and just by listening to you developing the spider, the scraper, it just like already bring back my headache. So I'd like to assure you that trying to find and scrape data all over the place, like Hy-Vee and other places, they're all differences. They didn't design for like machine to read. It's such a lot of work, and it's just like hair pulling work. And well, but you guys did such a wonderful job, and it's much more further, much more advanced from like last year, from what I remember. And I remember last year we do scraping, and then I just like go into weeds fields and some co-ops to just like face-to-face interviewing them and get like a paper list, and then try to put them in and try to match with different kind of like apples and all the produce. So this is great, wonderful job. And well, I think then the scraping part is always going to be tricky. And I don't know, have you figured out how to, well, maybe create a plan for like a scraping pipeline, because this site is going to keep changing. And if you can make a plan that is like reusable, then for when the new DSPG next year come, they can like build on top. That will be wonderful. So that's
Actually,
my take.
I do have that planned out. So I thought of that in advance. Like last year, we didn't, everything broke. And I was like, okay, what about next year? Like, is it gonna break? I mean, well, this cycle will continue. So I thought of just making something general and then making it super malleable and dynamic. So then like if the website does change, like you said, like you did, it would only need like, you would just need to replace like certain key areas in the code, and then it would just work. So like the pathing itself, like that stuff, if you change the website, the pathing all will change, and you would have to go through and do that part. However, the tool wouldn't break at that point. Like it's just that simple fix, and then it's done. Or if you wanted to add or change different products, you go into the files that are organized, and it's all labeled. It's a whole bunch of documentation went into that part. I spent quite a bit of time on doing that stuff. And it's all super changeable. Everything should not break unless you really try to break it. Which I have done a whole bunch of stress testing. Like I've spent probably over 200 hours testing and making edits, and I would go and wake up in the middle of the night and run the code and to see like if it will break, and watch it and go back to bed and try again the next day, because I don't really want to overwhelm the site and make it unfriendly for other people. So like if I stress the website too much, it might crash. And I do not want to do that whatsoever, because that is not very good. And also the code is able to change, and you can optimize it, advancement. Actually, like just yesterday, I learned of a technique that would supercharge the code and make it run super fast. But I didn't have time to implement it honestly, because I'm doing this today. There are a whole bunch of other techniques that I've been learning.
You had an extra 12 hours. You would have.
There is a whole bunch of other stuff that I've been learning, and I wasn't able to apply it. So like this past week, I found out a website that had a whole bunch of tips on how to improve your code, and I didn't have time to add it. But yeah, it's should be expandable. It should not be too difficult. If it breaks, I made sure to do this in advance. Yeah, and from the tools, like at the bottom, I made my own tool to help with it. So I built off of those. So it should be good. I mean, it's all original work.